Hi everyone, welcome to my Pecha Kucha. My name is Cobra and I'm presenting aluminum recycling. Through this presentation, I will walk you through the step-by-step synthesis of alum. On the right side of this slide, you will see the molecular structure of the alum, and I'm hoping you like this presentation. Aluminum has many applications, as you see few in this slide. Every year, we create 1.5 million tons of waste worldwide by throwing away aluminum cans. This not only fills up landfill, but it wastes energy and causes extensive environmental damage in creating new cans. Aluminum recycling saves around 95% of the energy needed to make the metal from raw materials. It also saves around 95% of greenhouse gas emissions compared to the primary production process. By recycling aluminum foil, you make useful alum compound. Let's have a look to the glasswares and materials needed for the synthesis. 250, 150, and 50 ml beakers. Glass steering rod, a small test tube holder, 10 ml graduate cylinders, 2 transfer reagents of potassium hydroxide and sulfuric acid. On the analytical balance, accurately weigh approximately 0.1 gram of aluminum foil and record the mass in your laboratory notebook. Next, weigh 1 small and 2 large filter papers and record the mass in your laboratory notebook as well. The synthesis will be carried out in the following stages. Tear the aluminum foil into the very small pieces on the weighing paper and place the pieces into a small test tube by folding the weighing paper. Now use the test tube tongue to hold the test tube and transfer to the next stage. Set up a hot water bath using 250 ml beaker. The water should be hot but not boiling. Then dispense 5 ml of 1.4 molar of potassium hydroxide into the test tube to dissolve the pieces of the aluminum foil. Mark the level of the solution and place the test tube into the hot water bath. As the reaction produces hydrogen gas, you will see bubbles and foam inside the test tube. Use a glass steering rod to push the foil into the solution. As the reaction proceeds, a small amount of the deionized water may be added in order to maintain the solution volume to the marked level. The reaction produces very soluble potassium aluminate. When the black precipitate settles at the bottom of the test tube, the reaction is complete. After 10 minutes of gentle warming, slightly cool the solution by placing the test tube in an empty 150 ml beaker on the benchtop. In the next step, add 2 ml of 9 molar sulfuric acid to the test tube, and this addition causes 2 sequential reactions. Both of these reactions are exothermic. The initial addition of the sulfuric acid forms the gelatinous precipitate of aluminum hydroxide. In this slide, you see the slow formation of gelatinous solid aluminum hydroxide. I would like to highlight that a 150 ml beaker is used for cooling down and hold the test tube securely. Return the test tube to the hot water bath and warm it for another 5 to 10 minutes or until all the solids have dissolved. Stir occasionally. Besides water, the reaction mixture now contains a slight excess of the sulfuric acid. As the excess sulfuric acid lowers the pH of the solution, the gelatinous precipitate will be dissolved. In the excess acid, aluminum hydroxide is converted to the aluminum sulfate and water. When the reaction is complete, place the test tube into the 150 ml beaker. Cool the reaction mixture by returning the test tube to an empty 150 ml beaker on the benchtop. While the reaction is cooling, prepare 250 ml beaker of ice bath. Carefully pour the content of the test tube into a clean and dry 50 ml beaker. Place the beaker into the ice water bath for about 10 to 15 minutes to allow the alum to crystallize. Scratch the inside of the beaker with a clean glass stirring rod if necessary to induce and speed up the crystallization. This slide shows how to carry out a vacuum filtration using water aspirator. Clamp Buchner flask to the ring stand using tri-prong clamp. The tubing connect the side arm of the tap water to the side arm of the flask, then add the filter paper to the funnel. Now open the whole blast of the tap water for a stronger suction and check the suction. With a few drops of water, the filter paper is wetted for a better sealing. Use a glass rod to direct the solution from 50 ml beaker when pouring into the funnel. Collect the alum crystals by vacuum filtration using a Buchner funnel. Use a few ml of 50-50 ethanol water mixture to rinse the beaker, then pour it over the crystal inside the funnel. To turn off the vacuum, first disconnect the tubing from the Buchner flask, then shut off the water. The weight filter papers include one small filter paper used inside the funnel and two large ones. Place filter paper and crystals between two clean pieces of the large filter paper. Scrape off all the remaining alum from the funnel, and the right image is the crude alum. Float any excess moisture from the crystals, then fold up the paper and place it in an envelope. Keep inside the desiccator, then find the mass of this filter paper using analytical balance. The crude mass will be calculated from subtraction of the mass of the empty filter paper from the recent mass. The left slide shows my synthesized crude and pure alum. Alum crystals are commonly used in food preparation processes like pickling, fermentation, and baking powder. It's also used in water purification, leather tanning, and cosmetic use as a deodorant and aftershave treatment. Here is my reference slide, and I hope you enjoyed the presentation.